Okay, this is some notes on Target 5 for Unit 9, solving a non-right triangle using the law of sines. So, law of sines, for any triangle which could be right, but also acute or obtuse, you may use the following formula to solve for missing sides and angles. We have side A over sine of angle A, side B over sine of angle B, and side C over sine of angle C. The big takeaway here is that given a triangle, in order to be able to use one of these fractions, you have to both have this angle and the side across from it. So for example, angle A, maybe I know is a 40-degree angle, and length A is equal to 16. If I have both of those informations, okay, all that information, I have angle A is 40 degrees and side A is 16, then I have enough information to plug in an entire fraction worth. If I don't have both of those, if in an entire triangle I cannot find a way to get the angle and the side across from it, then I will not be able to use the law of sines. So that's my go-to rule here. To use the law of sines, you must have a side length and the angle measure across from it, and that's key. So we're going to kind of ask yourself that every time. Do I have a side length and the angle measure across from it to see if I can do the law of sines? So something else to keep in mind when you're solving, you're going to pick out two of these ratios and actually set up a proportion and solve. So I could pick those first two and set them up. It doesn't matter which two I'm doing. Another thing to keep in mind is that it works upside down as well. It's hard to see the upside down. So it works upside down as well. It doesn't matter with the proportion whether or not the angles are on top or on bottom, as long as you are consistent. We'll just do all of ours with the sides on top, but it really doesn't matter. So if you see it done a different way, it's really the same thing. Okay, so for this one, we are given an example 1, a triangle ABC, given angle 70 degrees, angle B is 80 degrees, and a side length A is 12. Find the measure of angle C and the sides B and C. We will not always give you the diagram drawn, so you need to practice drawing the diagram on your own. But sometimes we will. Anytime that I have two sides in a triangle, or two angles, sorry, you can add them and subtract from 180 to find the third angle measure. So I do have two angles. I have 70 degrees and 80 degrees. 70 plus 80 is 150. So if I do 180 minus that 80 plus 70, that means I'm doing 180 minus 150, which is 30 degrees. So that's, if I have two angles in a triangle, finding the third angle with the triangle sum theorem is a fast thing to do as a first step. So I have this 30-degree angle. My step 2 is to use the law of sines twice to find the missing sides. I wrote down use side A and angle A in case you made a mistake, when you're finding C, but really we're using side A and angle A because that's the pair that I have the opposite of. Okay, remember back in the beginning I said that you have to have an angle and the side opposite it. If you don't have an angle and the side opposite, you can't use the law of sines. So I'm going to start with angle A and side A because that's the pair I have. And so if I set up a proportion, I can set it up twice. I can say 12 over sine 70, which is my A over sine of A. Okay, both times. I can set that up to B over sine B and C over sine C. So using the numbers in the diagram to plug in for B and to plug in for C, I can solve. Okay, so B is 80 degrees, highlighted that in pink. So 12 over sine 70 is equal to B over sine 80 degrees. The other one was C was 30 degrees. So if I look up, angle C was 30 degrees. We're going to use that to find side C. And so for both of these, I need to cross multiply and solve. So I said, now using algebra techniques, you can multiply both sides by the denominator, or you can cross multiply and solve from there. So I've showed what the cross multiplying looks like. Cross multiplying means that we are multiplying across. So 12 times sine 80 is equal to B times sine 70. Or in the second one, 12 times sine 30 equals C times sine 70. And then you have to divide by the term you don't want. Okay, so in this case, I'm going to divide both sides by sine 70 degrees. Dividing and multiplying by the same number cancels it out to a 1. So b times 1 is b. Same thing on this side, divide both sides by sine 70 degrees. And then we're going to type in the calculator. When you use your calculator, if you have the pretty fraction button on your calculator, you usually don't have to worry about closing your parentheses. Side note though, if you do have a Casio calculator, I think they want you to close the parentheses or they won't let you do the problem. If you don't have the fancy calculator button on your Texas Instruments calculator, then I showed you in blue, you do need to add that parentheses or it will not divide it correctly. It'll let you divide, but it's following order of operations, and so since you didn't close the parentheses, it's not going to do the right math you want it to do. So I showed both of those, but either way, B we got 12.6 and C we got 6.4, so we had all the information we needed. Okay, a second example real quick with the law of sines. First question was, can we use the law of sines? Well, we look at the triangle. We have an angle, 38 degrees. We have a side opposite it. So we can use the law of sines because we have an angle and a side opposite. There's only one angle, so we'll go set up the law of sines. You can find angle A or angle B, depending on what you have. In this problem, we're going to find angle B because it's across from the side that we have. We have 27. So setting up the law of sines here. In blue, I have 29 over the sine of 38 degrees. And that's going to equal 27 over the sine of B. So cross multiplying is going to lead to 29 times sine of B is equal to 27 times sine 38. Going to divide on both sides by 29. And so sine of B is equal to 27 times sine 38 degrees divided by 29. We can type that in the calculator and we get 0.57. What that means is that the sine of B, in other words, the ratio that goes with angle B, is 0.573, and it just keeps going. Okay, I don't want the sine of B, I want angle B. Anytime we have the ratio and we want to find the sine or the angle measure, we're going to type in the inverse. Okay, so step 2, you found the sine B value, but now you must do the inverse sine to find the angle. So use your calculator to get the most precise answer. You could type in, on my paper, a lot of times I'll write down inverse sine of that decimal, 0.573. But in my calculator, I actually want to use this answer feature. Inverse sine of the answer. All calculators have that answer feature. On a lot of calculators, you press your second button, and then you press your negative sign button, which is down by enter, and that'll bring up answer, because right above this it says ANS. So when you do the inverse sine of your answer, you get 34.97, or approximately 35 degrees. So 35 degrees, it did all of that stuff to find angle B. Angle B was 35 degrees. I can then find the 107 pretty quickly by saying once I know two angles of the triangle, I can add them together, 35 plus 38, subtract from 180, and get angle A is 107 degrees. And I still have to find side A. So I've done all this math. I still need to find side A. So I set up the law of sines again. Cross multiply. Solve it out with a calculator, and you get sine A is 45. Side A is 45. And so those are all the steps you need to go through. Looks like we did about 4 steps or so to solve a triangle using the law of sines.